Okay, this is the video tutorial to accompany the SOL remediation for lesson 2. The topics we're going to cover are the same as we did in topic 1, in lesson 1, and you can pause them if you'd like to read through them. So some of these questions are going to look very similar, and that's just because we're trying to reinforce it. Hopefully, when you see this for the second time, hopefully when you see it for the third time, it'll be a little easier. And then by the time you see it on the SOL, it'll be the fourth time, and it should be much easier. So sometimes when they give us a picture and it asks which graph is shown and they give us a list of options like this, then our best option is actually just to type these equations in and actually just look at each picture. So as we switch each one on, notice that one was shaded on the wrong side. That one's also shaded on the wrong side. That one's the correct side, but notice this one has a dotted line, whereas the original one has a solid line. And you can see that this one does match perfectly. So just one by one, just type them in. You won't be able to overlap them quite like this because this picture would be on a separate screen. So focus certainly also on the intercepts as well. Just make sure that they go through the same places on the graph as they do on the original picture. Find all the solutions. So we're on to quadratics now. So for this one, we literally just type in the equation. Get the squared. You can open up the Desmos keyboard and hit the squared. Or you can press Shift and 6, which is what I do when I'm typing quickly. Whoops, I think that's supposed to say -6 actually. There we go. Whoops, slight little mistake on that one. I'll have to try and make sure I fix that before you see this one in class. So what we're looking for then is solutions. Some of those words all mean the same thing. So we've got solutions, roots, zeros, x-intercepts. And they all mean x-intercepts. So we're just looking, where does it pass through on the x-axis? Now, depending on what the question says, if it's a decimal, then that's fine. You can just take that. Often they will ask for fractions, so make sure you switch it. 0.667, like the example says for this, remember 1.667 isn't really that, and neither is 0.667. Now, it'll let you do a fraction, but it's the wrong fraction. So really, it's the sixes. We have to continue with that pattern. So notice the fraction to decimal buttons disappeared, but then it will come back by the end. So the answer for this one would be 2/3 if they specifically asked you that. Now, just as a reminder, not that this question asks for it, but if the question says factor, then you put in the opposite signs. So instead of -3/2, you would put +3/2. And instead of 2/3, you would put in -2/3. Oops. Now, as I'm looking at that, you can actually see this is clearly not the correct answer because the graph's wrong. So the other thing we have to do is we have to remember to bring these bottom numbers to the front of the question. So really, the 2 would just become 2x plus 3. And the 3 on the bottom here, I'm going to move it up here as well and make it 2. And let me just get rid of that a little bit there. And now what you'll notice is that's exactly the same question. So whether we're factoring quadratics or just solving, they all start by drawing the graph and then looking at what the x-intercepts actually are. And you could see sometimes they'll actually give you multiple choice answers. If they do, then this is even easier. You can click on the graph and you can check which one's the same. So A looks pretty good for this one. B you can clearly see is different. C you can clearly see is different. And D you can also see is different. So using that Desmos to match graphs up is a very powerful technique as well. If they use a different letter to X, you just change it to X and then you can type it in. So sometimes they'll actually give us a picture and ask for that information. So I put at the top all those terms, x-intercept, zeros, roots, and solutions. So when it says, what are the zeros, what I'm really looking for is, what are the x-intercepts? So for this one, 0 and 2. If it asks us for factors, remember we're just doing the opposite. So instead of +2, you would do -2. Now for 0, that's not quite so obvious. X minus 0 doesn't really make any sense. And actually, all we actually put is just x. So if we have 0 as one of our solutions, then the factor would just be x by itself. Simplify the square root of 192. So we type in the question. If it's a whole number, we're finished. If it's not, then we've got to go ahead and simplify. And to do that, we're just going to type in our table. So create a table using plus, change the rule to the number inside the square root divided by x1 squared, and then start from this number here. So it doesn't matter if you round up to 14, but you can just take the first part of the number, so 13. And it says keep counting down until you get 2 whole numbers. So go ahead, 12. Press enter, and immediately it already knows that you're on to 11. And then you can just keep hitting enter. And then once we get our 2 whole numbers, then we know we have the correct answer. Now, we think it's 8 square root of 3. I always like to just check just to make sure. If I type in 8 square root of 3, look at the decimal here, and then look at the decimal at the top. If they're the same decimal, then that's going to help you get that answer. If it's multiple choice, make sure you check every single one, because sometimes you might get 2 that have the same answer. When that happens, you pick the one that has the smallest radical, and that would be your answer for the question. So it says use the answer on the previous slide. So we already discovered that it's 8 and 3. So I know that part of the question already. So as I'm looking at this, I know that it's not answer A or answer B. So notice we don't type in the variable and the exponent when we're doing these questions. We just split them up into 2 separate questions. You'd work out the square root of 192, and then you'd work out the square root of x to the power of 100. And the rule for exponents is you half the exponent. So it's actually x to the power of 50. What it is not is it's not the square root of 100, which is 10, which they will put as one of your answers. So for this one here, that would be answer choice D. If they give us cube roots, just remember we're doing basically the same thing. To get the cube root button, you have to go through functions and then miscellaneous. But once you've typed it in, if it's a decimal, then you just create a table. But you divide by x1 cubed rather than x1 squared because it's a cube root, not a square root. Keep going until you get 2 whole numbers, and then you can pick out your answer from there. If they ask you to develop this, so if they put a number at the start of the question, just go ahead and work out what the answer to this question is, which we discovered was 4 cube root of 3. And then you can just times it by this number at the start. So 5 times 4 is 20, and that would give you your answer. This would probably be a multiple choice question anyway, so go ahead and type in the question, type in the answer choice, and just make sure that you get the same decimal equivalent. Functions, this is one of our last units. So which of these are functions? So what I'm looking at is I'm looking at the x values, and I'm looking to see if they're all different. If they are, then I'm going to select that one. So this one here, I can see I've got a repeat value, so that's no good. 532, they're all different, so that's good. And 576, they're all different, so that's good. So notice I'm not interested in repeat y values. That's perfectly okay, but they could put that in to try and trick you. So this is one where, notice it says select all that apply. So it is possible you can have a question where there are multiple correct answers. Domain and range. So domain just refers to the x values. Put them in order though, and no repeat values. So this would be 2, 3, and 5. And for our range, 4 and 6, even though there's 2 4s, we only put it once because, like I said, we don't have any repeat values. Match the equation to the graph. So I think the easiest way in Desmos is type in each one, look and see what graph it gives, find the picture, and then you can actually match them up with each one. There is a Desmos calculator here, so you could actually try that one. And I'm going to leave that one as it literally is just typing and copying. And you can see these are fairly different graphs. 2 of them have negative slopes, but certainly focus on the intercepts. One of them has an intercept at 1 and 2 on the x-axis. But this one has an intercept of, I can't quite tell, but certainly that doesn't have an intercept of 2 on the x-axis. Looks like it might even be 0.5 or 1/2. Exponents. So we got 3x squared. So this is our power to a power question. So we got 3x squared y times by 2x cubed all to the power of 4. So that means for this one, we have to do each term to the power of 4. So I got to do 2 to the power of 4, and I have to do x cubed to the power of 4. And the rule for this one is power to a power, you would multiply the exponents together. So 3 times 4 is 12. And 2 to the power of 4, and there is a calculator on the next screen, so you could go check. It's 16. And then I have to times this by 3x squared y. And remember, these are all multiplied together, so let me put a little dot in there just to remind us of that. Numbers first, 3 times 16 is 48. So we got rid of 2 answers straight away right here. They're hoping you're going to get lazy and just do 3 times 2, but it's not 2, it's 2 to the power of 4. X squared times x to the 12. That's where you're going to add the exponents. So 2 add 12 would give us 14. And then there's just that y left over at the end, which means that we would pick answer choice D. Just as that little reminder, if you're doing power questions, you'd use this one here, the a to the power of b. And that's where I got that 16 from. An alternative way, but this can be a little confusing to type in. This was what the question looked like. And you can see that there's an error symbol here. Now, if you actually type in the question, but wherever you see a Y, you put an X, it will actually draw it for you, as you can see here. Now, these were the 4 answer choices. So what I did is I typed them in one at a time, but wherever it says Y, I put X. And I did that for each of these. And then you can actually compare the graphs. So answer A is wrong. Answer B is wrong because it's not the same graph. C is clearly different. And notice D gives you exactly the same graph, which if you go back and look, is what we found out. It was answer choice D. So there is a way that you can check, but it's a little bit more complicated to do. But if you can remember, it's certainly one that you can use for multiple letters. Dividing, so just divide each term. 20 divided by 4 is 5. For the letters, we're going to subtract the exponents. So 1 take away 4 is -3. If we have the same exponent, then they can just cancel out. You could put y to the 0, but that's just 1. And then 5 times 1 is 5 anyway. So easy just to cancel them out. And 12 take away 3 is 9. Now, even if you're not sure at this stage, clearly it's not going to be the answer that has a 16 in it. And clearly for my answer with a 9, I know that it's not this answer either. So the reason it is answer B is, remember, anything with a negative exponent, you move it to the bottom, or you switch the position, I should say, from top to bottom or bottom to top, and change the sign as well. So that's why the answer is B, even if you didn't remember the whole rule for negative numbers. Same idea, you could type that question in again, but wherever you see any different letters, like Y and Z here, you just type in an X. For each answer choice, do exactly the same. Nope. There you go, you can see it's the second one. And if we go back, you'll notice I did pick answer choice B as well. And if we tried C and D, you'd find that these are incorrect answers. Properties, let's just go straight to the answer for this one so we can see. So this one, notice that the left and the right switched over, which is actually your symmetric property. Identity is when you do something and nothing changes. So like if you add 0, that doesn't do anything. Or if you times by 1, that doesn't do anything either. Inverse is when you do the opposite. So if you see like 5x, which means times by 5, you divide by 5. And reflexive is when the left and the right-hand side are exactly equal to each other. Collecting terms. Big thing to remember for this is, although you can only see 2 sides of this, remember actually you've got to label all 4 sides of these. So the top is going to be the same as the bottom. So although it's not labeled, the top is also 5x minus 2, and the bottom is 5x minus 2. Along the side here, this is 7x plus 4, and the left-hand side would also be 7x plus 4. Oops, I'm not sure I left quite enough room in here. And for perimeter, this is where you add all the exponents together. Now, I'm going to skip to one of my later slides because we actually can see this easier. So I added all the terms together and then just focus on the specific one. So if we focus on the x's, when you add them up, I can see I get 24. And I already know the answer is clearly going to be C just from that. And when you add the numbers together, 4 take away 2, add 4 take away 2 is 4. So we can see that that is the correct answer. Didn't think we really needed the calculator for this one. If you're not very good with your adding, you can also certainly use it for that as well. If you have realized that you're adding all the sides together, then you can actually just type in each answer choice and see, does it give you the same answer? And there you go. You can see that that third one is exactly the same. But to do this, you do need to realize that you're adding all 4 sides together anyway, but it can make it easier to simplify. It'll do it automatically for you. If it's just a straightforward collecting terms like you see here, you can just look for like terms. So 5a squared, don't forget the subtract in the middle here. Take away negative 2a squared, because these are like terms. 5 take away negative 2, I know is 7a squared. So I've narrowed it down to 2. And I have negative 3 take away 7, which is negative 4. So I can pick my answer choice C. And if you prefer, you could just type in that question, but notice I changed the A into an X, and you can match up each graph. Not the same, not the same, not the same. Oh, I got not the same this time. Something went a little askew there, but I can't see what went wrong there. Oh, I got careless. -3 take away 7 is -10. Whoops. So you can see why that's a good way to actually check that one. I did 3 take away 7, but I missed the negative at the start. So -3 take away 7 is -10. Very good reason to check on Desmos. Then you can always find any errors that you might make. One alternative way is you can actually type in the question with an A. It'll ask you to put in a slider. Don't select one, try and pick a random decimal, and then look at the answer that you get here, 27.03, and then look at each of these and find the one that also gives you 27.03. The reason you want to pick a strange decimal is sometimes when you pick one as an answer, you'll actually find multiple ones that will give you the same answer. Not quite this time, but sometimes that happens. Arranging things into slope-intercept form. So slope-intercept form is the ones that start with y equals. Standard form is when x and y are on the same side. If you have x standard form, these must all be integers and x cannot be negative. So easiest way for this one is type in the question, type in each answer, find the one that looks exactly the same. Check all of them just to make sure we don't have any repeat answers. But you could see for this one, clearly only answer A had the same picture. This time in reverse, so this is slope-intercept form because it starts with y equals, and here are my answers in standard form with x and y on the same side. So I got the question typed in, and I got each of my answer choices typed in, looking for the one that gives you the same picture. So it looks like it's answer choice C. Let's make sure we check all just to make sure. And you can see that that's clearly the only one that has the same picture. Therefore, that must be the correct answer. For systems, just a reminder, you type in the question, and literally all you're looking for is where do they actually cross. Now, if you can't see where they cross, then all you're going to do is you're just going to zoom in or zoom out until you can see, and then you should just click on there. Remember, this refers to the x value, and this refers to the y value. If they use different letters in the question, just switch them to x and y, and then these should be okay. Now, the other option is you type them in, and you notice that they're parallel. So when they're parallel, we ask, do they cross? The answer is no. Therefore, the answer is no solutions. If the lines are exactly the same, then we're going to put infinite solutions. Now, if you only see one question, it's very tempting to want to just put straight away infinite solutions. But remember, there could just be a line that's higher up that's just off our screen. So you might want to zoom out to check, but probably even easier is switch one of the lines off and then switch it back on again and see if it's exactly the same line. This one you can clearly see is the same. Doesn't really matter which one you switch off. Then therefore you can tell as it's the same line, this one would be infinite solutions. If we have a word problem, there's a lot of possibilities we could have for this one. Burger and fries, I'm going to use B for burger. I'm going to use X for burger, sorry, and I'm going to use Y for fries because I know when I type this in, otherwise it will not work. So one burger, one X, plus one lot of large fries, sorry, plus Y equals 6.08. And for the other one, 3 burgers, so that would be 3x, and 2 large fries, 2y, equals 16.45. And the question says, how much is it for a burger? So burger referred to the first letter I typed in, so I'm going to be looking for the x value when I get to my next page. So I already typed them in ahead of time. Click on the intersection. So if you click on one line, then it'll actually put the dot there for you, and you can click. So the burger's 4.29. The fries are 179, and therefore you can pick the one that's relevant for this one, which would be answer choice C. Find the slope between 2 points. You can definitely use y2 minus y1 over x2 minus x1. Absolutely, you can use that. Or you can just include them in a table. So plus, select table, type in your 2 coordinates here and here, and then use your modeling equation we know we're going to need at some point in this test anyway. y1 still mx1 plus b, and then your slope at the bottom here will be the number for m. So m refers to the slope, as in the number in front of the x, and the other number tells you your y-intercept, and you can clearly see on this picture that it goes through 7 as well. If I was to change the scale a little bit, we might actually be able to see a little bit more as well. possibly we could actually figure out that this slope is -1/2. It goes down 1 and it goes across 2. Down 1 and across 2. So we can use that to help us as well if necessary. If they give us a picture like this, so this is our Hoy and Vux question because we're looking at horizontal and vertical lines. This is a vertical line, so I'm thinking about the word Vux, V-U-X, and therefore you can see the slope is going to be u, which is undefined. What is the equation for this one? So it starts with x, and then just look where does it go through x on the x-axis. So it goes through at 2. So I would be selecting this answer and this answer. And if we're not sure, we could, of course, just type in some equations and try and check to see which ones. So we had 4 answer choices and see if it's the same one. That one looks pretty good. No, totally different, totally different, totally different. So there is that if you totally forget about which one you're supposed to do. What is the equation of a horizontal line? So when I see horizontal line, I'm thinking about that word Hoy straight away. And therefore, I know my equation starts with y equals. Looking at the two numbers, 3 is the x value and -7 is the y value. So I could type in y equals -7. For the vertical one, v-u-x, I know that x equals, and then this time it's just what the x coordinate is, which is 3. X equals 3. Now, you could also, of course, try typing some of these in as well. If you think that they're the answers, check. Does it actually give you the line that you think it actually does? Does it give you the vertical line or the horizontal line? And I actually typed in x equals each number and y equals each number so I could check. Notice I included that coordinate down here. It says that it must pass through 3, -7. So that one did, so I know that's a possible answer. That one I can see did not, so I know that would be a wrong answer. So if it is multiple choice, you can use that to help you as well. Modeling, we just did a second ago. So you would type in these coordinates and we find out which is the best one. If it's a straight line, we're going to use the y1 still at mx1 plus b. And if it's curved, we're going to use the one that says ax squared. So let's take a look to see what's in. So as I got this typed in, you can clearly see that this is curved. So it will let you type in the y1 Sedilla thing, but it's not going to be the correct one. In fact, you can check. That doesn't look too good. But when I type in the squared one, you can certainly see that looks pretty good. And then from here, a is 1, b is -3, and c is 2. So this would be 1x squared, just plugging it into here. -3 for x, so -3x, and then plus 2. Sometimes we'll have that follow-up question. What's the prediction for when x equals -4? So if you type it in, all you're looking for is where do they cross? And then you can pick out the answer from here as well. Variation was our very last topic we did. This was right at the end of the course. So we have our two values. We have v and r, which is not y and x, but hey, we can improvise if we need to. You can actually type in the coordinates. And I would always include 0, 0. Remember, if it's a direct variation, this is a straight line going through 0, 0. So this is clearly not a straight line. So I know this is not direct variation. So I can get rid of 2 answers straight away for this. I can get rid of A and I can get rid of B. For my other 2 answers, I can actually type in each of these questions as well to figure out which is the correct one. So let's have a look to see. Nope. And you can see that that one does go through these 2 points here. Now, the reason the answer is 80, or 80 is an important number for this question, is because for inverse variation, we multiply the 2 numbers together. So 20 times 4 is 80, but notice 16 times 5 is also 80. We can ignore 0, 0. That was only to check if it was direct variation or not. So actually, it should have said 80 times r. So I think I actually typed in one of these 2. Also for inverse, if you see the division, you know that this is going to be an inverse question. And that was one of the other reasons why I tried both of these 2 things as well to see. Solving equations, you're just going to type this in and let's see what happens when we get to that. So you type in the question and it might say, it will actually draw it, but it kind of draws it a little strange. So I would not type it with a Y. I would change it to an X so you can see. And then literally all you're going to do is look, where does it cross on the X-axis? And that's your answer. If you have an inequality question, you type it in. Look which side is shaded, so to the left. So pick the inequality that also points to the left. As this one doesn't have an equal sign, the answer will also not have an equal sign. But you could see that also from the dotted line. Anything with a dotted line is not going to have an equal sign. If you see a solid line, if I can just add in an equal sign here, just so you can see, and let me switch that one off, you can now see that it does give you a solid line for those ones. So that answer was x is less than 6. So fairly easy to do as well. Now, sometimes though, when you type a question, you won't see the picture. Now, you should certainly zoom out first just to check. I've already zoomed out to negative 100,000 and I don't see it. So this is a problem. So this is probably no solution or infinite solutions. So split the question up to the left-hand side and the right-hand side, and then graph those two parts individually. Now, I only see one line here, so I'm going to switch it off. And hopefully you can see this is exactly the same line. So same rule we did for systems earlier. If you see the same line, you're going to put infinite solutions. And if you see parallel lines, you're going to put no solutions. So for this one, this would be infinite solutions. The reason it is infinite solutions is kind of obvious for this one, but you won't always get as easy as this. If you distribute 2 times x, 2x, 2 times 3, 6. So they're identical. That's why we get infinite solutions. Variation graphs, which one shows direct variation? So I know that it's a straight line and it goes through 0, 0. So nope, nope. That one looks good. And that one does not. So I would pick answer choice C for this one. So pretty quick. Plot 3 points to make a direct variation graph. So no multiple choice, you've got to click physically on the graph. So obviously 0, 0, that would be your first point. And then from here, we know it makes a straight line, so we're just looking for the pattern. So look how you get from the dot to the other dot. You go up 1, and then you go across 3. So do the same thing. Go up 1, go across 3. Up 1, go across 3. And you can see that that would make your straight line. Now, there were other options as well. So as long as you pick 3 points, you should be good. But you should always start with 0, 0 for direct variation question. Distributive property, numbers first, letters second. So 2 times 3 is 6. X times x, as there's 2 x's, x squared. Or with the exponent of 1 and 1, 1 add 1 gives you 2. 2 times negative 4 is negative 8. X times w, you just put them in alphabetical order, so wx. They could try disguising the question by asking for the area of a rectangle and give you these two sides, and you'd have to realize then, oh, what they're asking is this times this, and then you can write it like that. Back to functions again. So what we're looking for is no repeat x values. So I see 2, 5, 0, and 2. There's a repeat on 2 here, so that one is no good. 1, 2, 3, 4. They're all different, so that's good. Don't care about the repeat 8s because they're y values. 5, 1, 3, and 2. They're all different, so that's good. And on the last one, 2, 3, 2. There's a repeat on 2 again, so I would not accept that one. So answer choice B and answer choice C would be good for this question. And it's a little easier to see on here. You can see the repeat x value here, and you can see the repeat x values actually twice. The 3 are also repeated. For FOIL questions, originally when we did this, we did our grid. Now, specifically if it says squared, remember that means multiply by itself. So in other words, 2x plus 5 times 2x plus 5. So you can certainly draw a grid out for this one and fill in the answers. 2 times 2 is 4. X times x is x squared. 2 times 5 is 10, and there's an x. 5 times 2 is 10, and there's an x. And 5 times 5 is 25. So certainly ones that end in 25, I know I can get rid of this one. I know they've got to have 4x squared in. Oh, well, they all do. And it's what do I do with these terms here? So the ones in the middle that are identical, these are ones that you add. So the multiplication is only at the start, because a lot of people want to do 10 times 10 and pick 100, which is the wrong answer for this one. So after you've finished it, this part here is the addition. So 10 add 10 would give you 20, and therefore that would be the correct answer. Now, if you are given multiple choice answers, though, I would not actually be drawing the grid at all. I would actually be typing in the question, and I'll be typing in each answer choice. Remember, if they're not X, just go ahead and type in X. So you can see answer A is not the same. You can see that that answer is the same, though. Not the same, and not the same. think I switched these around. I think on the other one, that was actually answer choice B. So for this one, yeah, answer choice C, 4x squared plus 20x plus 25. Just check one more time. Yeah, you can see that's the same picture. And if you did do it by hand, there was just a reminder. But don't forget, this question also could be an area question again. So they could be asking, what's the area of this square? And you'd have to know it's 2x plus 5 times 2x plus 5. Don't label all four sides for this one. That was the perimeter question. So make sure you're aware of the differences between those two. And that's our second run through. So we looked at 18 different questions again. Some of these will obviously be repeat questions as well. Like you might get asked more than one question on FOIL. You might be asked more than one question on modeling. So that would make up some of those 45 potential questions that you're going to have to answer for the SOL. That's it for this one. We'll do the follow-up one for lesson 3, where we'll make the questions also possibly just that little bit more difficult as well.